Okay, so I haven't been entirely honest with you when I was talking about how easy it is to write the electronic configurations of transition metals. So they are kind of funny, and there's actually two exceptions that you need to know about. Okay, so for the most part, using the periodic table to write your electronic configurations is going to get you out of a lot of trouble because it correctly predicts that you fill the 4s electrons before the 3D. Okay, and the same goes in like period 5, you fill the 5s before the 4D, etc., etc. Okay, but there is exceptions. In fact, not wanting to scare you, but the further down the periodic table you go in terms of like periods 5, 6, 7, you get increasing numbers of electronic configurations that are actually anomalous. And this is actually, I don't want to scare you, to do with like relativistic effects, like the heavier the electrons get, the more they do weird stuff. But this is Gen Chem 1, we're only going to worry about the first row transition metals. So the problem children are chromium and copper, which is convenient because they both begin with C's. So I'm sure you can think of some way to sort of be like, oh crud, the ones that begin with a C are the weird ones, right? I tried not to do the English thing and use a cuss word there. Okay, so they have anomalous configuration. So all these first row transition metals, we're going to use the condensed electronic configuration. So the core configuration is going to be taken by our friend argon there. That's going to take care of those first 18 electrons. So for scandium, titanium, vanadium, they're going to follow the same trend of 4s filling before the 3D. So we've been given cobalt and nickel, so we might as well go ahead and do them because they're normal. Okay, so here's cobalt with Z equals 27. So for cobalt, you're going to write argon, and then 4s2, and then 3D, let's count along, 1, 2, 3, 4, 5, 6, 7. So 3D 7 will be our cobalt. Nickel here with Z equals 28. Again, the same thing, core configuration is going to be taken care of by argon. Then the 4s fill first, and then along with 3D, we've got 1, 2, 3, 4, 5, 6, 7, 8. 3D8. Okay, say I had chromium, you would think it would be 4s. Sorry, argon, then cool, 4s, 2 there finally, and then 3D, 1, 2, 3, 4. But you would be wrong. Okay, so for chromium, this is our first one you have to know that's anomalous. Okay, it actually has a 3D5 configuration, so it has one less electron in the 4s, and it gets promoted up to the 3D, like so. And this is possible because the 4s and the 3D orbitals are actually very close in energy. So what you end up having is a more stable configuration of each of these orbitals having just one unpaired electron in them. So this is my 4s and my 3D. Give me an arrow. So for chromium, you actually have this situation. So remember, like charges repel. So even though it costs more energy for one of those 4s electrons to be promoted into the slightly higher energy 3D orbital, okay, because of the minimization of electron-electron repulsions, the overall energy cost of the 4s1 3D5 configuration is lower, okay? So just remember, chromium, weird, right? You have a 3D5 configuration. And we see the same thing happening for copper, okay? So copper, you would think, is argon 4s2. This is painful to even write. 4s2, 3d9. Okay, looking at its position on the periodic table, but you'd be wrong. Oh no, now I've got that and I can't make it go away. But actually the same thing happens, okay? That it is better in terms of energy to get rid of one of those s electrons from the 4s and put it up into the 3d so that you minimize the repulsions in the 4s orbital. So it actually has the configuration. Are you going to let me undo this? Please let me undo it. I can't see it anymore. So you actually end up with a configuration that copper is 4s1, 3d10. That is very slightly lower in energy than the alternative of 4s2, 3d9. So for the first row transition elements, those are the only two that you need to know. So you know them now, right? So you're not going to get caught out if you get asked for chromium on copper. Okay, awesome.